In section 6.7, we're going to look at some exponential and logarithmic models. And the first type involves compound interest. And so here are a couple of formulas that should be familiar to us. And so A is equal to P times 1 plus R over N to the NT provides the balance on an account where interest is compounded N times per year. And A is equal to PE to the RT provides the balance where interest is compounded continuously. And recall that E is approximately equal to 2.718. So here's an example. We want to determine how long it will take $1,500 to double in an account paying 4.5% interest, compounded quarterly or continuously. Okay, we'll start with quarterly. Okay, so we're going to use the first formula, A equals P times 1 plus R over N to the NT, where P is 1,500, R is 0.045, which is the interest rate converted to a decimal, N is 4, since quarterly is 4 times per year, to the 4T, and this is equal to, when the balance doubles, the final value will be $3,000. It may be helpful to simplify the expression inside the parentheses, so I'm just going to add 1 and 0.045 over 4, and we get 1.01125. Okay, we're going to isolate the power, and to do that, we'll divide both sides by 1,500, and we find that 2 is equal to 1.01125 to the 4t. Okay, at this point, we recognize this is an exponential equation and can be solved using a couple of methods. One is if we could write the powers on each side with the same base, as in 2 to the x is equal to 4, and then I could have 2 to the x equals 2 squared, and so x is 2. That's not the case in this example, as this base on the right cannot easily be written with a base of 2. Okay, instead, we're going to use a logarithm to solve. So we can do one of two things. We can just take log of each side. Okay, use the power rule to rewrite the expression on the right. Okay, we get log 2 is equal to 4t times log of 1.01125. Okay, and divide both sides by 4 log of 1.01125, and we find that t is equal to log of 2 divided by 4 log of 1.01125. Okay, and now we're going to just evaluate on our calculator. Okay, so enter this expression into the calculator. Be careful with your parentheses, and we see that this is about 15.5 years, 15.5. Okay, another option for solving this equation is to just start back at our exponential equation and rewrite in logarithmic form. So we could have log base 1.01125 of 2 is equal to 4t, the exponent. Okay, and once you isolate t, we find that log base 1.01125 of 2 divided by 4 should produce the same answer. And let's take a look at B. So this time we want to find how long it will take for the account to double if interest is compounded continuously. So we're going to use the formula A equals PE to the RT. And P again is 1,500. A is 3,000. R is 0.045. And we're solving for T. So isolate the power. Since the base is e, we can use the natural logarithm. So natural log of 2 is equal to natural log of e to the 0.045t. And recall one of our properties of logarithms is natural log of e to the x is equal to x. And we see this is true because those bases are equal. And so in this case, natural log of 2 is equal to 0.045t. And lastly, divide both sides by 0.045. Okay, so we find that t is equal to natural log of 2 divided by 0.045, which is approximately 15.4. Notice it takes just a little bit less time to double if the interest is compounded more often.